Okay, now that we know how to reduce radicals from watching the previous video, what we're going to start in Chapter 7 is using the Pythagorean Theorem with right triangles. Notice this, anytime you have a right triangle, you can use the Pythagorean Theorem to find missing information about the triangle. Inside the idea of right triangles, you have two things. You have sides and angles. Those are the things that make up a triangle, so it makes sense. Using side, when trying to solve for sides of a right triangle, you want to use the Pythagorean Theorem. Pythagorean Theorem works perfect for solving for missing sides of a right triangle. But when you're looking for angles in a right triangle, you can either use the triangle sum, whereby the three angles add up to 180 degrees, or you have to use something called trig, dealing with sine, cosine, and tangent. We get into trig a little bit in this chapter, but for the most part, at the beginning, we're dealing with sides, looking for the Pythagorean theorem. So let's look at the theorem itself. In a right triangle, the square of the length of the hypotenuse, by the way, if you are not familiar with it, the hypotenuse is the longest side of a right triangle, and the easiest way to find it is find the 90-degree angle and go directly across. The hypotenuse is the longest side. It is across from the 90-degree angle. The square of the hypotenuse is equal to the sum of the squares of the other legs. So if you look at this right triangle here, we have the two sides. By the way, it doesn't matter which side you label as A or B. It does not matter. The only leg that matters, or the only part, excuse me, because it's not a leg, the only part that matters in a right triangle is the hypotenuse. You have to label that C. The other two can randomly be labeled A and B. But the way that you use the Pythagorean theorem is you square the hypotenuse, set it equal to the other two squared, and add it together. Very straightforward theorem, very straightforward formula. Let's just start practicing it. Look at example 1. In example 1, the first thing we're going to do is actually go through and start labeling the parts. We're going to find the hypotenuse, label the side across it C, and then label the other two legs A and B. Here's the 90-degree angle. If I go directly across from it, not the sides next to it, across from it, that's my C. Then I can randomly label the other two A and B. I'm going to go A and B. You could go B and A, it doesn't really matter. In this case, my X is going to be the side A. Now, what I want to do is use my Pythagorean theorem, which is C squared equals A squared plus B squared. Now that I have everything labeled, I have my formula, I'm going to go through and actually start filling in all the pieces of information I have. I'm going to take out C and put in 5, take out A and put in X, take out B and put in 4. Now I have a problem I can solve. Now when I square something, I multiply it by itself. So when it says 5 squared, I'm multiplying 5 times 5, which is 25. 4 squared is 4 times 4, which is 16. And I'm still looking for X. So the way that I do this is get X by itself. I want to subtract 16 from both sides, and I'm quickly running out of room. Drop down my X squared. And in this case, X squared is going to equal 25 minus 16, which is 9. I'm going to rewrite it over here just so I have room to solve it. Now, if the opposite of addition is subtraction, the opposite of multiplication is division, then the opposite of squared is a square root. The way that you undo something that is squared is you find the square root of it. The square root of X squared is just X. The square root of 9 is 3. It's a perfect square. So, I use the Pythagorean theorem to solve for a missing side length. Hopefully you can understand that. Let's go to the next problem. Again, the first thing that I'm going to do, actually the first thing I'm going to do is erase this, because I have no room to write. But the first thing that you should do is go through and label the hypotenuse as C and the other two legs as A and B. Now here's my 90-degree angle. If I go across from it, that's my C. So I'm going to put a C right next to that. And then I'm just going to randomly label this one as A, this one is B. You could have done it the other way. It doesn't really matter. It works out to be the exact same answer. Then over in between the two problems, again, I'm going to write the Pythagorean Theorem. C squared equals A squared plus B squared. Now I'm going to go through and substitute, take everything out that I have, the C, the A, and the B, and replace it with what I know. And the problem I get is x squared equals 4 squared plus 6 squared. Now what I need to do is just square stuff. 4 squared is 16. 6 squared is 36. 16 plus 36 is 52. Now, just like the previous problem, I need to find x, not the square root of it, or not x squared. I want to find just x. So I'm going to do the square root of both sides. The square root of a square is just the number, so x comes out. I'm going to solve it over here. The square root of 52 is not a perfect square. And so what I need to do is find out, is it prime? Will the square root of 52 reduce at all? And this is where you really needed to watch that previous video on reducing radicals, because if you write down the square root of 52 as an answer on a quiz or a test, I can't give you credit for it. On the ACTs, you might not find the square root of 52 as an answer. You might find it's a reduced radical, or you might find it's decimal, but you won't find the square root of 52. So we need to reduce it. When I reduce 52, I'm going to divide it by 2 first of all. I get 2 times 26. 2 won't reduce, but 26 will. So I'm going to reduce 26 into 2 times 13. Oh, look, I can take 2 times 2 and make 4. And I get the square root of 4 times 13. Or square root of 4 times the square root of 13. The square root of 4 is a perfect square. It's 2. And so I get 2 square root of 13. And that's what I need to do. I need to reduce that answer and get 2 square root of 13. Now, there are times when you have special combinations of numbers so that you can always figure out what the missing piece is. And let me show you what I mean. Go to the next page, and we see something called Pythagorean Triples. Now, sometimes we can cheat. Shh, don't tell anybody, it's okay. When we're finding out a missing side length, the reason we can do this is because some triangle measures are always used. For example, 3, 4, 5. You see that we just previously used it in our first problem. We had a leg of 4, a leg of 3, and a hypotenuse of 5. That's called a Pythagorean triple. Now, there are some Pythagorean triples that are used quite often. 5, 12, 13. 8, 15, 17. 7, 24, 25. And you might see these pop up on your homework. Now, you'll still need to solve it. You'll still need to show me your work so that I can verify that you know what you're doing. But there are times when you'll see a Pythagorean triple and you can identify and immediately know the missing side. Maybe you see a 5 and the hypotenuse is 13. Remember, the hypotenuse is always the longest side. Maybe you see a leg of 5 and the hypotenuse of 13. Without even solving it, you could guess that the second leg, or the missing side, is 12. Now notice this. You can also multiply a Pythagorean triple by something. Maybe you multiply the Pythagorean triple by 2. Maybe you multiply it by 3. Multiply it by 10, so on and so forth. It's still a Pythagorean triple even though it's a bigger number. Realistically, though, to start off, you need to know how to reduce radicals. You need to know how to solve the Pythagorean theorem. Okay? This is going to help you out later in the chapter. In the next couple chapters, when we deal with breaking down quadrilaterals in Chapter 8, one of the ways that you solve quadrilaterals is by breaking them down into right triangles. Chapter 9 deals with rotating and reflecting objects, and one of the things that we rotate and reflect is a right triangle. You need to know how to solve the Pythagorean theorem, as well as, whenever you take Algebra 2. Maybe you've already taken it and you can see that you use squares and square roots in Algebra 2, or maybe you're taking it next year. Trust me, you have to do squares and square roots. There's really no way around it. And the only way to really get better at it is to practice it. And so I'm going to write it down one more time just so you can see it. This has to be the hypotenuse. And it helps to label, the parts first. And these two can just be the legs. It doesn't matter which leg you pick as long as it's a leg. But you'll notice the hypotenuse, leg, leg. The only way to get better at this is just to practice. So let's go ahead and look at your homework right now.